Okay, this is the second way you might have done the Zurich one. I'm going to use a logarithm here. So what I did was I used the normal x, which was the length in centimeters, and I did it against the log. Whoops. So this is the log. It's not writing very well. The log of, and our y value was height. So I'm going to put ht for height, which was in centimeters. I did that for the y-axis. Okay, and I know some people are going, okay, maybe it's going like this or something like that. Maybe, maybe not. It's kind of hard to tell. Again, 5 points is hard to work with. Well, here's the residual plot for that model. And again, someone might say, well, it's got a pattern here. It might. It's 5 points. It's hard to tell. So usually you have more data so you get a better idea of the shape. As opposed to the first time when we looked at the data, it was clear that it just fit here. Here it may or may not be. I'm just going to put a question mark here because I'm not. You can see the model seems to be good. It's only got 5 points. Seems to be, when I use this as well as criteria, and with that, it may be an okay model. So what is the model saying? It's saying you will get the predicted logarithm of the height if you do 0.0104 times the length plus 0.6113. And the reason I'm carrying more decimals is when you deal with logs, you really want to get lots of decimal places. Okay, because they become powers and it makes a big difference. Every little bit makes a big difference. So you want to write at least 4 decimals for logs. So the log, the predicted log of height is, well, we want to put 0.0104 and we will put 145 in there plus 0.6113. Okay, so we're going to get the predicted log of the height. So I get that there. And now you have to remember what logs are. Remember, logarithms, when they're written as logs, is base 10. So this really means the height is 10 to the power of 2.1193. So what is 10 to the power of 2.9113? Okay, so let's type that in here. Okay, so I put that into the calculator, 10 to the power of 2.1193, and I get 131.6 centimeters. Okay, and we were supposed to compare that to 125.9 with our other model from the previous one. So they kind of give you the same thing, but don't forget, these are predicted heights, and because we had nonlinear, we re-expressed them. We got to really deal with these things here in a manual, because this was not the answer. That was the power for the answer. Okay, so there's a couple ways to do it. Now I have a problem with this one. I'm not sure about the residual plot here, and it's not quite as good a model, so I probably would have gone with the first model.